All right, so let's take a look at number 34. So I've got to simplify each of these expressions, but I don't have to evaluate, which is a good thing. So on your formula sheet, you're going to find some formulas that are really helpful. So I see 2 sine 17 cosine 17. That's the sine double angle. This is sine 2 theta equals 2 sine theta cosine theta. In this case, obviously, theta was 17. So if I double 17, then I have sine of 2 times 17, which is the sine of 34. So in this case, I'm looking at the sine of 34. And I don't have to evaluate, so I can leave my answer right there. Now the next one I notice, this has got to be a cosine sum. Remember that with cosine, you change the sign. So this was subtraction. It's going to be addition. So in this case, I have cosine of pi over 7 through pi over 7, which of course is just the cosine of 4 pi over 7. And the next one I see is a sine difference. Now in sine, I don't need to change the sign, so I'm still going to subtract, even though in cosine, I do not need to do that. So this is the sine of 7 minus 3, which of course is just the sine of 4. And the next one I notice is a tangent difference. So this must be the tangent of 11 plus 25. And that's the tangent of 36. Now the next one I notice, that's got to be cosine 2 theta, because I see 1 minus 2 sine squared theta. In this case, theta was pi over 9, so cosine of 2 theta would be cosine of 2 times pi over 9, which of course is just cosine 2 pi over 9. Next, I see that I've got another cosine sum and difference. Remember, I've got to change the sign, so this would be cosine of 8 minus 5, not 8 plus 5. So then that's the cosine of 3. Now down here towards the bottom, I can tell based on this being 1 plus cosine theta, it's got to be cosine of theta over 2. So in this case, theta was 23, so this would be cosine of 23 over 2, which is the cosine of 11.5. And last but not least, I see that this must be another sine sum. So this would be the sine of 7 pi over 13 plus 5 pi over 13. And when I add those two together, I'm going to wind up with the sine. Evaluate these, so I can just leave it as is. Next, I see that they told me what cotangent is. I find it more helpful to think about tangent. So the tangent of A would be 5 over 12. And based on what A is, I know it's got to be in quadrant 1. So let me sketch out what this triangle would look like. So the opposite side would be 5, the adjacent would be 12. And if I use the Pythagorean theorem, then I would wind up finding that the missing side is 13. And I really should have used the letter A instead of theta, so let's go back and do that. So that's A. So just so I can keep track of it, I'm going to also notice that sine of A would be 5 over 13, and the cosine of A would be 12 over 13. Just in case I wind up needing those. Now, first I'm asked for sine of 2a. Well, I know that that's 2 sine theta cosine theta, and I already found the sine of theta was 5/13, and the cosine of theta was 12/13. So when I multiply all that out, I have 2 times 5, that's 12. 12 times 12, pardon me, 2 times 5 is 10. 10 times 12, that's 120. And 13 times 13, that's 169. So I get 120 over 169. And next I see that I've got the cosine of 2 theta. Well, the cosine of 2 theta, or 2a, is, you can use any of the 3 different formulas. I'm going to use cosine squared minus sine squared. So cosine squared, that's 12 over 13 squared, minus sine squared, that's 5 over 13 squared. And when you do the multiplication, you square everything, you're going to wind up with 169 in the denominator, obviously. 12 squared, that's 144. 5 squared, that's 129. So when I subtract the two of those, I'm going to wind up with 119 over 169. Now next, I see I've got the sine of theta over 2. So I know that's 1 minus the cosine of theta over 2. And I can just leave my answer as being positive since I'm in the first quadrant. So I wind up with the square root of 1 minus 12/13 over 2. And now 1 minus 12/13. If I change the 1 into 13 over 13, and I subtract 12/13, then this is going to turn into 1 over 13 over 2. Now I can simplify that even a little bit more. So that'd be the square root of 1 over 13 times 1/2, and that of course turns into the square root of 1 over 26. Now next, for cosine of theta over 2, when I have cosine theta over 2, I add 1 plus cosine theta. So this time we're going to almost the same thing as last time, except we're going to add 1 plus 12 over 13 over 2. And when I add together 1 plus 12 over 13, I wind up with 13 over 13, because I want to change 1 into 13 over 13. So 13 over 13 plus 12 over 13, I'm going to wind up with, let's change this, 13 over 13 plus 12 over 13 divided by 2, just so we can all see what's going on. So 13 plus 12, that's obviously 25, so 25 over 13. Let's change it into multiplication. So we got 25 over 13 times 1/2. So then that becomes the square root of 25 over 26. Now, number 36. I see that I need to solve the following equations. I'm going to start with letter A. And I'm going to start out by subtracting the root 2. And then I divide both sides by 2. So I wind up with sine theta equals negative root 2 over 2. Okay, so I need where sine is negative. Notice this isn't sine inverse, it's just sine. So I could have two different answers for theta, either in quadrant 3 or quadrant 4, because that's where sine is negative. And I see root 2 over 2, so that tells me it's got to be the 45, 45, 90 triangle. So my solutions there have to be 5 pi over 4 and 7 pi over 4, since I need the 45, 45, 90 triangle. So 5 pi over 4, 7 pi over 4. Now the next one, I'll start out with 3 cosine theta plus 4 equals 5 cosine theta plus 5. And I'll start out by subtracting 3 cosine theta on both sides. So then I have 4 equals 2 cosine theta plus 5. Subtract 5 on both sides. So now I've got negative 1 equals 2 cosine theta. And you probably already guessed, we divide by 2. So I wind up with cosine theta equals negative 1/2. So, okay, cosine is negative. So if I'm dealing with cosine being negative, then I know that I must be in quadrant 2 or quadrant 3. So in this case, change it up, I'll do degrees for us this time. Theta is 120 or theta is 240. And I need to include both answers since I'm asked to give all the answers between 0 and 360. Number 37. Letter A is pretty simple. I subtract the 1 on both sides, so I get tangent x equals negative 1. And if tangent's going to be negative, then I know that I have to be in either quadrant 2 or in quadrant 4. And if I'm talking about tangent being 1, then it must be the 45, 45, 90 triangle. So x would be 3 pi over 4. That'd be my answer in quadrant 2. Or if in quadrant 4, 7 pi over 4. Now, I thought it was helpful in this problem to rename the signs to be x's to make this easier to factor. So I see when I make it look like this, that the factors are 2x minus 1 and x minus 1. So now I'm going to replace 2 sine x minus 1 equals 0 and sine x minus 1 equals 0. So this would turn into 2 sine x equals 1. Divide by 2, I get sine x equals 1/2. Sine is positive, so I know I have an answer in quadrant 1 and 2. So x is pi over 6 and 5 pi over 6. And my other equation is pretty easy. I just need sine x equals to 1. That only happens in one spot. That's just pi over